In the last video, we created a jEPlus project with only 3 parameters, each associated with one numerical field in the shoebox model that we wanted to modify. This time we shall add a few more. The first one is infiltration. Infiltration is often an important factor affecting your building's heating and cooling loads, and it's quite easy to change as well, especially at the early design stage, where its impact can be evaluated using a design flow rate. Okay, so let's see how to do it. I have already jEPlus open, and let me get my previous project. It's here, and this is the IDF model. I'm looking for the infiltration object. It's here, and at the moment, the infiltration flow rate is defined as a flow per zone. I would like to use air change per hour. So what I need to do is to change this field to air change per hour, and then remove this number, but instead put a search tag in this field. But to be sure what is the option to put in here, I'd better have a look at help. Okay, that's the same object, and if you scroll down, you see the field for design flow rate calculation method, and this is the exact option that we want to use in jEPlus in the model. So I paste it here, and then remove this field and put a search tag there in a moment once we have that parameter created. So now let's create a parameter. So this one is called infiltration. Just put an infiltration there. And now I can put this search tag in this place before setting the numbers. Now for values, I want it to be 0.03 at an increment of 0.01 up to 0.09. It showed me nothing because I need to change it to the double type. Okay, and also from 0.1 at increment of 0.1 all the way to 1. Now we have a whole list all the way from 0.03 to 1. Okay, so those are the values we want to test for infiltration. There are a few other things you may wish to change if you want your infiltration flow rate to be variable depending on the temperature difference and wind speed, etc. And you can find the relevant numbers if you from the menu. So that's the object. If you go to the reference field, and you can see how the infiltration flow rate value is calculated from the parameters you have specified. And there are some recommendations of the numbers you should use to determine the wind speed coefficient and temperature coefficients. Okay, so this is infiltration. Next up, construction type and insulation level. In the jEPlus model, each building surface is associated with a construction. Since most of the surfaces in our shoebox model are adiabatic, we're only interested in the external wall, which is this one. And this is the construction name. I'll make a copy of it and paste it there. You should find us the construction object where the layers of materials are defined. You can see it has a brickwork as the outermost layer with cavity wall insulation, concrete blocks, and then plastering. Right. To vary insulation level, we want to change the thickness of the insulation layer. So that's our insulation material. So let's do a search again. And you find the material object with that name in here, and the field for thickness is right there. So now I can add another parameter called insulation thickness. So another one, insulation. And for value, I want to vary it from 0.05, that's 5 centimeters, to at a step of 0.05 all the way to 0.3. I think that'll be enough. Okay. So from 5 centimeters to 30 centimeters. And I'll put a search tag in this place. Okay. So what if you need other constructions? The simplest way is if you can reuse the existing materials and just by rearranging the order of them and create new wall types, for example. I can make a copy of this. I'll make 2 copies of this. So the original one, I'll call it wall cavity. And this one, the second one, I change it to solid wall with external insulation. And the third one be wall with internal insulation. Okay, and for external insulation, the outermost layer should be some kind of rendering. I will use gypsum plastering, which is not right, but I doubt if it will make any difference in the simulation results. I put it as the outermost layer and move the insulation layer to be the second, then the brick layer. I don't need the concrete blocks anymore. So that will be the wall with the external insulation. And similarly, the wall with internal insulation. So the first 2 orders is right. We don't need a concrete block. And that's it. Okay, and now we have 3 different constructions ready to use in our wall surface. So let's go find our wall surface. I think it should be somewhere. It should be somewhere here. So now this model is quite small. I can just scroll and find it. But in most cases, you will need to search. So this one is referencing the project wall. Remember, we have renamed it to wall cavity and wall external and internal. And we will turn this field, the reference to the construction name, into a parameter, which means we'll add a new parameter now. So this one is call it wall construction. And we'll put a search tag in the place of this. Right. And for the field now, we have to use explicit list. So it's wall cavity. You should note one thing. When I put wall cavity there, because of the space between wall and cavity, jEPlus will interpret it as two different options. You see the extra comma here, and that's not right. So in this case, you need to encapsulate it with a pair of quotes. So that's wall cavity, wall external, and wall internal. Now it's quite easy to get to have a typo in there, so you'd better go back and copy and paste. That'll be safer. Otherwise, it's quite difficult to spot a typo. You can see the value type doesn't really make much difference. It should be discrete. So in this way, jEPlus will know to put wall cavity in the place of this search tag when it's running the models. We can actually make it even easier. Say if you put wall space before that search tag, then the search tag can be used to only fill in the missing word. So in that case, we can put just cavity, and we don't even need quote marks. Internal there. And when jEPlus runs, it'll put cavity in the place there and make the whole text become a wall space cavity again. So that's I should reference the correct construction type. So I should save this file and do a test run, because we have made some changes to the model, and we better do a test. So let's go to execution. We run the first job again. Yeah, still doesn't take long, and we can have a look at the results, see if everything's there. Quite long. So there's our original parameters. Now we have an infiltration level, we have a insulation thickness, and the cavity wall. That seems alright. And jEPlus finished with no errors. So that's a good sign. That means our copy and paste creating construction was okay. And there's absolutely no heating demand, which is actually pretty much as expected, because the heating set point is very low. The infiltration level is very low. Insulation, there's some at least. So yeah, in our model it shows no heating, so that all seems fine. Remember to close Excel every time you look at the results tables, because when it's open, jEPlus will not be able to write output tables, and it doesn't know why, so it will fail. You don't get new results. So remember to close it whenever you look at results. Okay, a few other things to mention. This is a very simple way to create new constructions, but if you need new materials or need specific constructions that you can't easily edit in this way, there are a couple of other ways to get them. The first one is, of course, go back to your original model and change construction of the surface you want to. Say in Design Builder, it provides lots of different constructions. Really too many. Can't even easily find the one you want. So I would not bother. I'll just change it to any one, and then you export the model again, and open the exported file in the text editor and find your construction and the materials you used, and copy and paste those into your model template. This sounds like a little tedious, but over time you can collect your own library of material and constructions, and things will get a little easier. For constructions and materials, you can put as many as you want in the same IDF model, even if you don't need them, or the model don't reference them. jEPlus will give you warnings, but it doesn't interfere with the simulation at all. In jEPlus distribution, there is a construction library already. So if we have IDF editor here, and if you go to Files and Open Dataset, you'll see one is called Archery 2005 Hall of Fame Materials. Well, it's not Hall of Fame, it's Handbook of Fundamentals Materials, but anyway. It has over 200 material definitions and 15 different constructions, and some special materials representing R value and air gap, etc. So plenty to choose from. So you can actually go find this file and copy and paste the whole content into your model, and then you can reference any of the construction types directly from there. I'm not going to show you how to copy and paste here, but that's the idea basically. Right, so that's about construction really. You can use the same process for window constructions. This model is exported from Design Builder and they still use numbers for window construction and the materials, which is slightly harder to understand what they are. But the process is exactly the same. And you can also use it for schedules. See, you can have as many schedule objects in your model as you like, and use a parameter to control which one is actually used. And of course, you can change the field within each schedule object, like what we did with heating and cooling set points. Next, let's look at the geometries. Shading first. Okay, so models exported from Design Builder uses detailed objects, geometry objects for all the surfaces, including shading. And basically that means the geometries are defined using vertices. As you can see, it's quite difficult to change its shape or size, even with a rectangular shape with 4 vertices. So the way to do it is actually replace the whole surface with a simpler model provided by jEPlus. For that, we could use IDF editor to create a different model for us for that surface. So let's go to IDF editor and create a new file, and we're looking for thermal surfaces, and all we're looking for is a shading overhang. As you can see, in this object you can use a number of values to define the overhang rather than using the vertices. Okay, so let's create a new object and give it a name. We'll call it overhang. We don't know the window door names yet. We'll fill in that later. Height above window door, we keep it as 0, so right above the window, and that's 90 degrees, so that's horizontal. Left and right extension, I'll give it 0.3 for both. And the depth, okay, keep it at 0.5 meters. Okay, now we filled in some numbers. Now we can make a copy of this object and go back to jEPlus and paste that in. You can see I just pasted in a line of text with our numbers in there. Now this is not arranged in the more readable way, but we know the missing field here is actually the window name. And For that, we need to find our fenestration surface and reference it. And it's right above our original shading device. So this is our window. And that's the window name. Copy that and paste it in here. And you should remember to remove the first one, that IDF text. This is not what a IDF model need object. Now we can get rid of this one. And we shall turn the depth of the overhang into a parameter. So let me add another parameter. Overhang depth. And give a few numbers. 0. I don't know. 0.2, 1. Change it to double. We have a few numbers again. Okay, another object you could use is shading overhang projection, and the difference with of this project with overhang is instead of defining the depth, you can define it as a fraction of the window door's height. This will be very useful if we are changing the window size, which is what we are going to do next. So maybe we should use this one instead. Let me create another object. Just copy. Paste there. The only thing I need is actually that. Now that's the shading overhang object, overhang projection object, and now this value is no longer a length, but rather a fraction of the height of the window. So 0.5 means half the height of the window. Now we can still keep our parameter values, so ranging from 20% of window's height to 100%. Now, of course, I need to copy and paste in the search tag here, save the model, and run a test again. It's always a good idea to test your model whenever you make some changes. This time I want to see how the geometry looks like. There are two files actually, it's in here. I have a DXF here, which is the 3D model, but it's not a format I would like to view on this computer. So unfortunately, we have to go back to jEPlus and to our model and add another output. And this time we have a VRML. Saved file, run it again. Good, it doesn't take long. So this time we have the VRML output. And on Windows machines, you can just double click it and you'll see your model popping up. We have a tiny little overhang over there, but that's exactly what we want, isn't it? So that works fine. Now let's get into the last topic we're going to discuss in this video: how to change the window size. First, let's see the object used in our jEPlus model for Windows. For models generated by Design Builder, it uses a detailed fenestration surface, which you can see again using coordinates to define the geometry of that window. Now this is difficult to work with because there are so many numbers you need to take care of. And actually on the jEPlus website, if you go to the menus, and this is actually a copy of the original menu, it goes in length to discuss how you can deal with coordinates using different methods. But nevertheless, this is quite laborious. The best way to deal with that is actually get rid of it. Instead, we can use a much simpler object in jEPlus to represent the window. And that one is called window. Okay. So if you look at this object, let's create a new one. It needs a few fields. Should need a name. I'll put a name here because I need to change it to match the original Windows service name. I need to reference a construction, and I'll place a placeholder here as well to be changed later with our model. And it needs to be associated with one building surface. So again, just a placeholder. I'll change those later. Our window doesn't have shading control or frame or dividers, so we leave those empty, and the multiplier will be 1. And to define the geometry, use the coordinates that's relative to the region of the base surface on which this window resides. So you need to define a starting x and z coordinates. Where the starting point is actually defined in the global geometry rules. See, the first field is called starting vertex position. We can actually go back and check what it is if you search for. I think GL will do. Try again. So global geometry rules. The first field is where the starting point is. It's a lower left corner. I think that's most model use anyway. So let's get back to our fenestration and get back to our IDF editor. So this means we can specify one corner of that window and then specify its length and height. That will be a lot easier to parameterize. We put something here to mark the place. Okay, and then copy this object and paste it into our jEPlus model. I'll put it right above here. Oops. Okay, remember to remove the first IDF. So it'll be a window object. It needs a name, it needs construction, it needs surface, and then we need x, z, width, and the height. Right. So now I can copy things over. So get the name in here. The construction is actually that one. So construction name you can see there. Surface is the next field. Okay, I'll leave the next two fields empty. And this is the window multiplier. It should be 1. And the first thing we need to parameterize is x. The next one is z. And the third one is width. So this time I'm defining the search tag first, and then we go back to create those parameters, and that one is height. Okay, so 4 search fields, and now let's go create those parameters. So the first one we need to add is the width of the window. So width. And we'll call it W and give it some numbers. It'll be from 0.5 at a step of 0.5 up to 3 up to 4, I think. Okay, change it to double, get a long list of numbers. Now the maximum width of your window should not be bigger than the base surface, right? So this is our base surface, the external wall, and Design Builder will insert some comments here, and from there we know it's 12 square meters. And we remember that block is 4 by 6 with a height of 3. So this wall is actually 4 meters wide and 3 meters tall. The maximum width for window is 4 meters, but that sounds a bit too extreme, so I will reduce it to 3.5, so it doesn't occupy the whole width of the wall. And similarly, we can add height. I made a copy of the previous one. If you do that, remember to change the ID, because you can't figure out the ID automatically. So this is height. Height. This one will be H. And it's 3 meters high for the wall. So we reduce this to 2.5 meters. So the maximum height of the window should be 2.5 meters. Right. So we have the parameter for width and height defined. The next one we need to figure out how to define X and Z, because that should be dependent on the width and height. And for that, we need to do some calculations. And how this calculation is done is best illustrated using this diagram. Right, you can see this is your base surface, and in the model it's still defined using coordinates. But we don't have to worry about that, because using the window object, or your window coordinates is relative to the region of that surface, which is 0 and 0. In which case, it's very easy to figure out what the coordinates of the lower left corner by knowing the width and height of the surface and your width and height parameter. And this is the formula you can use. Basically, you find the center point and then move it down and to the left with half width of the window, right? So that's fairly simple. So we just need to put those formula into jEPlus to define the starting point of that window. We add another parameter. This time it's X. So X of this lower left corner. Call it X. And this time we were using a formula to calculate it. That requires a special syntax. It's called @calc. Okay. And we need the width of the surface first, which is 4 meters, and divided by 2 minus our width parameter. So whatever value this parameter take, we shall use half of it. So P7 divided by 2 and closed bracket. Now jEPlus will interpret @calc and show it as a question mark equals, right? And it will try interpret the parameter you have put in as well. And this currently shows P7. That's actually not right, because in jEPlus it's case sensitive. The parameter ID need to be perfectly matched, so it's actually capital P. And once you've done that and jEPlus found that parameter, which must have been defined before this formula, it will put the search tag there in place of the parameter ID. In this way, you can know that jEPlus actually understand what this formula is. So that's how you calculate X coordinate of the starting vertex. We do the same thing for Y. So I'll make a copy and change it to Y, 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 and this time it's P8. Okay. So Y is calculated from the height, and you can check the formula if it is right. Right, so we have the parameters defined for controlling the size of the window. Now we can get rid of the original window block. Okay, save the model and do a test run. See, I said duplicate parameter ID. When I copy it, the formula from X. I forgot to change this, so it's quite easy to happen. So, but the good thing is jEPlus will warn you about that, so that's all right. Okay, it seems I finished a little bit too quick, so there must be something wrong. Let's go see what happens there. This is the new folder it has created, and we shall take a look at this, the error message. Okay, so there's a fatal error, and the information is actually in this line. So the window object, the value type, is not permitted. If this happens, it normally means that search tag hasn't been filled with the number. It remains as a search tag. So you could open the IDF file and check, but I'm pretty sure that's what it is. So let's go back and check. So where's our model? So, see here, we were expecting a Z as the search tag, but instead of I called it a Y. Change it back to Z. Probably should change this as well for the sake of consistency. Okay, and let's test again. Slightly pause, that's more likely. And we can go back to our folder, check the error message, load it. Now it looks very different. And jEPlus completed successfully with no severe errors. That's so much better. And we can look at our model. There we go. See, a tiny little window there, as we defined in the parameters. So this is exactly what we need to do to conserve energy, right? Have small windows on old buildings. Anyway, so this works. The next stage is actually test the whole project. So so far we only tested the first value. If you want to make sure that all the values work, you need to do a larger sample and to contain all different values in there. One quick way to do that by using random sampling. Okay, if you go to execution and change the run option to a random sample and use LHS, because Latin hierarchical sampling will ensure that each parameter value will be included in the sample. So we give it a sample size. Let me see. The one with most values is actually this one. It contains 17 different values. All others has fewer alternative values in them. So if we put 17 there, ideally that 17 cases should have odd values from each parameter. Now let's see if it works that way. I'll run a simulation of these 17 cases. It still doesn't take very long because the models are very quick. Okay, close it, and let's see the summary report. Right. First to see there's no errors, which is a very good sign, and jEPlus have all completed successfully, and we see a long range of different values. Where's my 17 different values? It's the infiltration. So if we add a filter and sort it, see, it's nearly perfect. We got all the values I need in that. Well, it is perfect. and we can sort other ones and see if we got all the variations in there. Yeah, it looks pretty good to me. It's not equal number of cases, but nevertheless you have all the variations in this tiny sample. That's the power of Latin hypercube sampling. So you got cavity, external, internal. So this is a very effective way to test that all your parameter values will work in that project. Of course, the next step is to run some simulations, get numbers, and do some useful analysis. If you go back to jEPlus and validate the project, you will see we already have nearly 13 million different cases, and no one can possibly simulate all of them. So you're most likely to use random sampling again. There are other methods, especially using the tools like jEPlus EA, and we'll cover those in future talks.